We are going to solve these exponential and logarithmic equations here using inverse operations. And the main relationship that we are going to be using today is log base b of a equals c can be rewritten as b to the power of c equals a. So we're going to use this relationship to solve for the variables in these three examples. So we're going to start out with this first one. We have 4,000 equals 9 to the power of x. We are going to rewrite this using this relationship here. If we were to rewrite this in exponential form, we are going to have log base 9 of 4,000 is equal to x. We can put this directly in our calculator to solve for x. If you are using your graphing calculator, if you press math and you scroll down to log base, it will give you the option to type in the base and the argument of this logarithm. When we put this in our calculator, we find that x is equal to 3.775, and so that is our answer for this first equation. Moving on to the second example, here we have an exponential function, so we are going to use a logarithm to solve for x here. When we are using logarithms, the first thing that we want to do is we want to make sure we are isolating our base and our exponent. So to do that here, we want to divide both sides of our equation by 450, and that is going to isolate e to the power of 0.5x on the right side of our equation. It's going to leave us with 2.22 on the other side of our equation. Now that we have isolated our base and our argument, we can rewrite this equation as a logarithm so we can solve for x. When we rewrite this as a logarithm, we are going to have log base e of 2.22 is equal to 0.5x. And if you'll remember, a logarithm with a base of e is the same as what we call our natural logarithm, which we can easily enter into our calculator. So we could rewrite this as instead of log base e, could be our natural log of 2.22 is equal to 0.5x. If we take the natural log of 2.22 and we divide it by 0.5, we're going to put that in our calculator, and it is going to leave us with our answer of 1.595. And so that is the value of x in this second example here. For our last example here, you'll notice that our logarithm does not have a base. If we have something that says log of x, that is the same thing as log base 10 of x. So if there's not a base written, then we know that the base of this logarithm is going to be 10. So if we were to rewrite this logarithm in exponential form, we are going to have 10 to the power of 3 equals x. If we take 10 cubed, we are going to get 1,000, and that is going to be our value of x. If you need to solve for logarithmic or exponential functions, you can use this relationship here to rewrite each equation so that you can solve for the variable.